Welcome everyone. Today I'm with Ricardo Michel Reyes. Can you, Ricardo, please introduce yourself? How would you define yourself in a few words?
Awesome. Well, thank you for receiving me in your podcast, Thomas. I'm Mexican, first of all, but I've been living outside of Mexico since I was 17 years old. So I have pieces from everywhere in the world in my culture. I've been living in Spain for 4 years now, which is the longest I've been in a country since I left Mexico. Um, and yeah, most of my AI career I actually developed in Spain. In Mexico, it's hard to do AI. Nowadays, it's advancing a lot, but when I started, no one knew what AI was, and selling AI
Mhm.
to people was very hard. Um, so I couldn't actually be an AI person in Mexico. In Mexico, I was mostly doing like apps and websites and like simpler things. My
Mhm.
my AI, like deep AI career, really boosted in Spain. So now I can call myself an AI person. I've been doing AI for 14 years, but like having really successful AI companies just been 4 years, which is Erudit. So now I'm the chief science officer of Erudit, which is based in Miami, but most of the tech team we have in Spain. So that's why I moved to Spain.
Awesome. Thank you. I would directly like to ask you about Erudit. So, can you tell us more about what is Erudit and how, what is your role in Erudit and kind of maybe give a bit of retrospective?
Sure. Erudit originally was an education platform. Like my business partner Alejandro Martinez, he's Spanish from Madrid. He invented this algorithm to using people's navigation on the internet, figure out how did they learn, if they were like more auditory people or visual people. And he even went to Harvard to interview this guy about multiple intelligences, because not only logical mathematical intelligence is important, but also like kinesthetic and interpersonal. So he won a lot of prizes with that, and he needed like a more advanced or production ready version of his algorithm. So we met through LinkedIn, and then I moved to Spain to work for him at the education company. But we finished the project in 3 days, so I was in Spain with nothing to do, and we started chatting about like what's next, and um, we figured out that in the human resources industry there was a lot to do about people's emotions and training. So we started with a training platform, but then we realized people weren't willing to pay for that. So the product just mutated and mutated and mutated. And what it is now is a platform that takes data from people's communications. So, like Zoom, Slack, Teams, all the main communication platforms. And then it inputs that anonymized data into several layers of neural networks to figure out if they are or not, what's the probability that they will quit in a month or so. Then, like, how engaged are they with the company, if they're happy with their workplace, if they're happy with their team, if they feel they have freedom to express their ideas and like propose new ideas, and like several metrics that from other products that normally do service we have seen that are important for companies, also talking with a lot of chief operations officers across the globe. So right now, I think our main advantage is that everything is done automatically. Like normally surveys, they have to be filled out by people. So you first have to make everyone answer the survey, and then people mostly tell you what they think you want to hear. So nobody is going to tell you the truth in a survey. It's always like, oh yeah, my boss is the best and I'm super happy. And so all of the engagement surveys are like 5 stars all the time, because people just say whatever you feel good and save their job. But this thing really, like, it Our main issue is privacy, of course, because people are very scared of like, oh my god, then you listen to chats and then, but you cannot pinpoint any single person from the platform. It's just like a, a view of the department. So you can see like the sales department is burnt out, the marketing department has a lot of retention problems, and yeah, and it's a lot of AI, like because it's very hard to analyze chats. It's very short messages, and then like people talk about all sorts of random things. So you need to select the messages that actually contain burnout information. So it's been language is the hardest part of AI, I think, and it's advancing a lot with things like ChatGPT, for example, that it's now fashionable. Um, but yeah, there's lots and lots of works in NLP, especially NLP when you have to be concerned about privacy nowadays.
Hmm. Mm. Yeah, privacy and NLP is something I want to ask about. I have a lot of questions that comes, like for example, the inputs of the model. Like, do you do you use only the messages, or do you have like a mapping of the employees with their age, and you try to like build an overall input? But this is a more technical question, and you mentioned chat gpt. So this is a very recent tool, if I'm correct. So you're saying that you've already implemented it into the company.
Not exactly, but like okay. So we can start, for example, with the input of the models.
Hmm.
Uh, there you have
I mean, I'm
huh?
sorry. I changed my question because I wasn't sure. This is something that you can share, but I would love to hear more about the inputs, and how it works a little bit in
Sure.
more technical.
The thing there is like when you're building AI for production, you have
Hmm.
to consider a lot of things because when you're doing AI for research, like in academia, the most important thing is that to prove that you have advanced the state of the art, which is mostly about accuracy with some like defined metric by another paper, you know. So
Hmm.
then you have
Hmm.
like the blue score, the rouge score, like lots of scores that have been creating by academia in other papers, and then everyone
Hmm.
agrees that that's the metric they should measure, and then it's like just improving that metric. So it's a game of accuracy always. But so for example, in terms of accuracy nowadays, you have all the transformer models, which their main, so these are autoencoder models that use the attention mechanism, so they don't take all of the words with the same weight, but like some words have more weight than others, which is pretty obvious for any human. Like in every language, most of what you say is just to fill out grammatical concerns, so people can parse what you're saying. But the semantic content is mostly in two or three words in the sentence. So the attention mechanism does this inside of the model, and then transformers are normally the best models for NLP nowadays, right? And then like transformers give you good accuracy, but the problem is that they can get really big. For example, ChatGPT, it's interesting because it's based on the GPT-3 model,
Hmm.
just trained on a very skillfully selected like data set, and it also incorporates reinforcement learning as a way to improve the responses that this gives. So it's very nice because now you have like reinforcement learning who has been successful, for example, with DeepMind, all the Alpha Zero, all these models that are really good, like the one that won Lee Sedol in the Go game, like that's reinforcement learning, right? So now you
Hmm.
have transformers, which are the best from NLP, with reinforcement learning, who has been proven in another all sorts of tasks, and you put them together, and that's why you get so good results with ChatGPT, right? But you can, so that's awesome for academia, like that's awesome for marketing stunts, that's awesome to get funding. But in real life, these models are very costly because of a lot of things. Like of course, if you want to consume the ChatGPT API and like pay for their API, that's great. Like, but you need to have very few users, because if not, the cost becomes like hundreds of thousands really fast, you know. So for startups, like, you have two different worlds when you're going to production. You have like maybe three different worlds. You have the startups, which you have to be very low cost. You have corporates, where you have to be like scalable. And you have public sector, where you have to be able to run on premise, you know. So then also corporates has on premise problem. So then when you're training a model in real life, not in academia, uh, you have to have a lot of concerns that are not in academia, which is performance and cost. So s- sometimes, like for example, the Berta is an amazing model in academia. We are using it for performance, but then when, sorry, for accuracy, but then when we want performance, we have to use a distilled version of one of these models, right? Because otherwise
Mm-hmm.
it's too slow, or it's too fat on memory. So because you need to have a GPU alive to run it fast enough. So
Mm-hmm.
also you cannot have like 8 GPUs. Like one GPU in any platform costs around 700 euros per month, which
Mm-hmm.
for a corporate is nothing, but then for a startup, uh, it can be significant if you haven't, if you have a small seed round, or if you have no VC round at all. So to just jumpstart an AI project, if you have to pay a lot of GPUs for your tool to function, because you used an out of the box huge model like Google models or Facebook models or OpenAI models, it's super hard. So in our case, we use like distilled versions of transformer models, and
Mm-hmm.
then like the input is just tokenized according to the model we use.
Mm-hmm.
The Hugging Face transformers library is probably the most popular to train and deploy transformers into production. But I
Mm-hmm.
think any major startup or tech company is probably using some like PyTorch with Hugging Face transformers for NLP,
Mm-hmm.
and probably like a distilled version of models and just attention tokenizers. Uh,
Mm-hmm.
we are now working also into incorporating audio transcription into the input of the models. But yeah, I don't know if that solves your question. Yeah.
Yes, that answers perfectly. I'm also wondering about the privacy in audio transcription. Um, but I have various questions. I think the first one, the most related one, would be if you would have to say regarding all the technologies you've seen. If you were to start again a SaaS software as a service, and you needed like a basic data architecture, like data engineer, it's more a data engineering question, and then I will ask you about quantum computing in the cloud to maybe solve those kind of problems that you were mentioning. But first, so you mentioned PyTorch. Um, I understand that a software as a service would be in the cloud to make an MVP, but how would you recommend to someone that wants to build an MVP with NLP, some tools and a basic architecture?
Yeah, so serverless architectures are the most cost effective. I'm thinking, so again, the three worlds, right? Like startups, corporates, public sector. Like for
Mm-hmm.
startups, or to just launch any, like, I don't have money or I'm gonna pay from my own salary in my project. Serverless is the cheapest. The problem with serverless is that normally they have a memory, a storage amount that your project has to be. It has to be normally lower than 250 megabytes. And PyTorch is like 700 megabytes. So you cannot fit PyTorch into a serverless, but you can do everything else in your website serverless. And then there's a serverless version of PyTorch in SageMaker in Amazon, for example. I don't know if IBM or Google have a similar thing. Probably they do. But the one I've used is AWS SageMaker, which of course they don't pay me to tell you. I use it, so I have no commercial interest in that. Just that's the one we use in it. SageMaker lets you deploy a serverless version of TensorFlow or PyTorch or whatever. So that's very useful to train. They also have special instances to train. For example, if you use EC2 or any like instance to train,
Mm-hmm.
you get charged by the hour. So the
Mm.
problem is you have to be really attentive to your consumption because, for example, it has happened a lot of times to me that I leave a task running and then I go to sleep and the task finished like at 3 a.m. And when I wake up, I already lost 4 or 5 hours of GPU time, you know? And
Mm.
if this becomes a common practice, you lose a lot of money there. The advantage of things like SageMaker is that if the task stops at 3 a.m., they stop charging you. Like the training task finishes, and then you don't have to worry about dead times of the instance. And then when you deploy, they charge you per every second of execution. So also, like if you have very few users, like in the beginning of your project, then it's super
Mm-hmm.
nice because you only get charged for whatever your users consumed. You don't have to have an instance running constantly. So
Mm-hmm.
yeah, serverless architectures and training and deploying with SageMaker has been game changer in terms of cost for us.
Mm-hmm.
And also the speed of inference is really good. Then I don't know, I got lost. Yeah.
No, yeah. So this would be for like someone that wants to build an MVP and want to have a very low cost data architecture. And then if we move to corporate and public, then I would assume that it's different. But my
Contain
question,
the
yes.
most important thing, like I think the biggest mistake we made in Erudit for corporates is that all of our, so we went serverless, which is awesome for startups, but then a lot of corporate companies or and public sector, so public sector most of the time they want it on their own premises. uh,
Mm,
and this also happens a lot for corporates, not necessarily that they have physical servers like public sector, but maybe they want to use it in their own cloud. Maybe they have a deal with Microsoft or they have a deal with IBM, which are the main corporate providers, and you did it in Amazon. So then you need to
mm,
move to Azure, and it's very hard to move from the Amazon services to Azure services. But if you use something like Kubernetes or like Docker to
mm,
have a microservice architecture, but inside of a Docker container. And
mm,
instead of Lambda, for example, in the case of Amazon, you use a Elastic container, which is the
mm,
same thing, but just with Docker.
mm,
Then you can just install that Docker into the Azure platform, and that gives you really fast integration with corporate and public sector. So also, if you plan to sell to corporate or public sector,
mm,
it's good if you Dockerize it from the beginning.
mm. Yeah, I think that's a great tips because I was myself looking at like structures, data engineer, like how to create the structure, and I was thinking of myself, will I create containers? Will I use Kubernetes and Dockers, and or will I just directly go on the service? And that answers directly my question. So thanks, thanks
Sure.
for the tips. Just before that, I wanted to get back on. So you were saying it's very consuming. Those models are very consuming, and we mentioned cloud computing.
Yeah.
Um, um, so cloud quantum computing. Sorry. So how do you see that quantum computing? Well, first of all, what's your point of view on quantum computing in the cloud? I know that IBM are working on servers that will be like that. How do you see? What's your point of view on this technology, and how do you feel that it can enhance what you are trying to do as building a lot of softwares with AI and Erudit, which enhance AI but is very costly to maintain?
Yeah. So, for example, um, there are two main uses, practical uses I see in quantum computing. One is, are you there, Thomas?
Yes, can you hear me?
You froze. Yeah. Okay.
Ah, sorry.
No worries, no worries. So one is when you have to model something that is quantum in nature, for example, if you're doing drug discovery or protein folding, or like in general, when you have something that is inertly quantum, you are working
Mm-hmm.
with spectrometry or in general chemistry, physics, simulations. If your
Mm-hmm.
product is very oriented towards things that behave quantumly naturally, then
Mm-hmm.
the results, the accuracy you can get from using a quantum computer is crazy better than what you would get on a binary computer.
Mm-hmm.
So then there's a niche in like biotechnology, like chemistry, very highly specialized, highly scientific areas. So,
Mm-hmm.
for example, for a General Electric or a Schneider Electric or like any pharmaceutical company, this is going to be a revolution just because of the inherent nature of the quantum computing, right? And
Mm-hmm.
then for more like businessy things or more like normal, let's say, applications, it's mostly about, for example, in the case of AI, you have already the Circ language that was developed by Google, and you also have QSKit by IBM to use
Mm-hmm.
their own computers. So Google and IBM already have deployed like quantum cloud computing,
Mm-hmm.
and you have to use either Circ or QSKit. And the good thing about Circ, for example, is that you also have TensorFlow Quantum. So you already have like a
Mm-hmm.
version of TensorFlow that is quantum accelerated. But nowadays the applications are hybrid. Like you do not run anything fully quantum. You only run
Mm-hmm.
the parts where the quantum computer is better. Because, for example, like in the 80s we had to create all of the, well, I wasn't even more, but people had to create the algorithms for very simple things like matrix multiplication, dot product of vectors, like search algorithms, and we don't have the quantum versions of that yet, for example.
Mm-hmm.
So then, but AI is mostly an optimization problem. And for
Mm-hmm.
optimization, the advantage of quantum computers is that you can run any possible result of a function at the
Mm-hmm.
same time. It's crazy how it works, but the quantum computer literally computes all the infinite possibilities of a function, like all the function complete
Mm-hmm.
in the same qubit because of superposition. So you can like AI is mostly like, okay, I go one step down of my optimization, like my loss function, and then I try again and I try again. This thing can compute all of the possibilities of the loss function at the same time. So you can
Mm-hmm.
train a neural network in one shot. Like instead of doing a stochastic gradient descent, you can like run your loss function and your optimization function in one shot,
Mm-hmm.
look at all the
Mm-hmm.
results and just choose the optimal version of the function. But then you have to build the quantum version of these algorithms. So there's
Mm-hmm.
a lot of work to be done in creating that, but we know how to solve small bits. So, for example, TensorFlow Quantum lets you run most of the algorithm in CPU or GPU, and then you can accelerate the small bits we already know how to do in quantum in a quantum computer. And
Mm-hmm.
like I've tested it mostly for vision problems, and vision problems like training because normally startup people or people who want to train their own vision algorithm go and download the weights, train on ImageNet or something like that,
Mm-hmm.
or Coco, depending on the problem. But you normally go to PyTorch or TensorFlow hubs and you download like the pre-trained version, and then you just fine tune, right? But
Mm-hmm.
these things were trained on hundreds of GPUs for 2 or 3 weeks, and in a quantum computer, you can train a ResNet 50 with ImageNet instead of in 3 weeks, in like a day or less. So it crazy speeds up the solution of any optimization problem. So it's gonna
Mm-hmm.
be huge when we discover like all of the algorithms we already have in binary computers in a quantum version.
Yes, because what's missing today is like to to re- to to
Programmers.
recode.
Like
Yeah,
someone that
programmers,
knows
right?
how to code quantum computers, literally. Like
And
someone that
is it
goes.
hard?
No, no, no.
I haven't had visibility. Like, is it hard? Like, just like for example, TensorFlow quantum. Is it hard to develop on this or?
That's what I hate about AI and quantum. Like because academic people have made it so that it's super scary. Like when I started doing AI, everything was like equations, and what the equation does when someone explains it to you in like normal language,
Mm-hmm.
it's super obvious. But then when you have
Yes.
to read the symbols and everything, unless you are like a very highly skilled, mature mathematician, or like with a background in physics or something where you have to do heavy lifting of math, uh,
Mm-hmm.
you read it and it's super scary. And then a lot of people abandon AI or quantum because they see the equation and it's like, oh my god, this is gonna be super hard. It's horrible. Bye. But for example, quantum computing works with circuits instead of like line. So
Mm-hmm.
if you have the patience and the humbleness to say like, okay, I'm gonna be stupid and I'm gonna feel super stupid, and I'm gonna be fine with not being the awesome programmer I normally am, because I think ego is a huge obstacle to learn quantum, because you come from being a highly regarded super programmer in another discipline, and then you come to quantum and you are completely useless. So that, because nothing transfers from one realm to the
Mm-hmm.
other, and
Mm-hmm.
then like you're a baby again, and if you don't allow yourself to say like, okay, I'm gonna be dumb, I'm gonna be useless, I'm not gonna understand anything, but I'm gonna be okay with it and just like work through patiently for maybe 6 months or something, uh,
Mm-hmm.
then if you get through your ego and through being patient, it's highly rewarding, because it's not that hard, it's just very different. And then
Mm.
you just need to allow yourself to get into something where you are not as good as your previous job. So it's like starting over programming.
Mm-hmm. Mm-hmm. Wow. Okay, that's very insightful. I will for sure look at more in depth of programming in quantum.
Yeah, it's not
Uh,
hard, it's just different. You need patience and a lot of trial and error.
Awesome. And so we can see very soon that to Erudit you will have some models that will have been developed with quantum, or this is not in the plans in the short term.
The thing is, in our R&D department, we do things for accuracy. So we have
Mm-hmm.
people focused only in getting more accurate models. Then we do things for performance, and then we do things to test the state of the art. So um, what we deploy in production is, of course, not quantum, because the the accuracy and the performance of something not quantum is still better, but we still develop things quantum just to be in the state of the art always. So then
Mm-hmm.
when the time comes where the quantum solution is better, then we deploy quantum into production. But right
Mm-hmm.
now, just the tools and the availability of computing and the cost is not better than just deploying normal stuff, but it's still cool to be there, because then you have experience. Like when the time comes, you have 3 or 5 years experience doing it quantum, while other people are just starting to think about doing it quantum. So we
Mm-hmm.
develop, but not for production.
Awesome. Thanks. Thanks for the tips. Okay, great. In our first call, we mentioned we started talking about public policy, ethic, and ethic around AI, and I would like to ask you more in depth about that. But first of all, how do you see ethic in AI, and what are the challenges we're facing today?
Oof. Um, so every technological revolution we've had, so just imagine, language is a tool, right? Language is technology. So
Mm-hmm.
then language is the first big revolution that, well, fire, it's debatable, but either fire, the wheel, or language
Mm-hmm.
were like the first of the biggest revolutions for humans, right? So when
Mm,
we invented fire, we were able to cook food. And when you can cook food, you can digest a lot of more calories in a smaller portion faster. So this
mm,
allows you to transfer time you would use digesting. Like you would have to nap. There are lots of animals that nap for 5 6 hours to be able to digest like all that they ate,
mhm,
or you'll have to waste time hunting more calories to compensate for your need for calories. But with fire, you
mm,
were able to process, for example, grains or meat that you wouldn't be able to eat, or fermented stuff. Also was a huge um, technology revolution,
mhm,
because then you have yogurt, cheese, like pickles, like things that you would normally get rotten really fast, and you didn't
mhm,
have fridges, so that that mm, that allowed us to spend time doing other things. Then the
mhm,
wheel allowed you to transport things from one place to another using less energy. And
mhm,
then language just changed everything, because then you were able to record all that knowledge for the next generation. So AI is not the first or the biggest revolution we've ever had. We've had a lot bigger revolutions. Agriculture, for example, private property. There have been other revolutions, but this is one we are living now. So then it's more relevant or more important because we have taken already wheels, fire, language, everything for granted. The internet, for example, we have already taken it for granted too. So
mm,
I would just say that it's important to dimension AI, like also light bulbs we take for granted. There are so many revolutions we have gone through that we have already taken for granted,
mhm,
but eventually AI will be one of these, like tap water, like light bulbs, like wheels, you know but
mm,
the problem with these revolutions is that they have created more inequality, because still, like, we live in Europe, and Europe is probably the most utopic, richest place on earth.
mhm,
And here, like, everything is super accessible. You can learn anything you want from the internet. You're not scared of being killed when you go out of your home. uh, like, you live in a state of peace, that we have taken for granted also. But there are
mhm,
other parts in the world, but there's people with no electricity, there's people with no credit cards, there's people with no clean tap water, there's people with no access to internet. So these revolutions have created more inequality globally. you know they have made the countries that are already really good and really technologically advanced richer, but also the ones that are not, further away from these countries. So
mm,
one of the things we have to be really careful with AI is not to create even more, because now it's going to be automated progress, because
mm,
ChatGPT can program things, or at least can seem like it programs things, and
mm, mm, mm,
you have autopilot from GitHub, which I have students that I do not use it because I'm scared that they will learn something that is intellectual property and then suggest it to another person. So I do not use it in my code, but I have a lot of students that use it, and the thing can suggest you a perfect autoencoder architecture, just clicking enter to everything it suggests to you, and most of the time it works. So then it's not going to be far away when AI can program other AI, and then it's just like a snowball. So
mm,
we have to be really, really careful, most of all, not to create more inequality with the rest of the countries.
mm. Okay. So, on an ethical point of view, today, because I remember this message. This, I think it was a tweet from Elon Musk, who was saying that mainly how AI is a huge tool. You were mentioning like when we invented the wheel and all of that, but like AI is a tool that can have an impact at a very high scale, uh, depending on the tasks it needs to be done.
Yeah.
How do we face, because then there is like, okay, so I have an axe. I always like to talk about like AI as a tool, like it's the same as an axe. Like with an axe I can cut a tree, but I can also harm someone. uh, with AI, it's the same principle, but at a higher scale, because we can build things that well, you mentioned that will probably be able to build AI, but also like um, we can do anything with a specific intention. So how we make sure in the future, in terms of laws, policies, how do we take this into account, like the how powerful can AI be, and what can we do about it? And yes, this is a question I'm wondering.
Oof, this takes us back to language again. One of the main things I've been working in my life is how language is just a set of contracts and agreements. And
Hmm.
like a lot of technologies have to do with that. For example, blockchain, which is just automated agreements. So I think that's like the key word, like agreement, because for example, you and me speak English because first the UK and then the US established like this world peace where they have naval or aircraft bases all around the world, and we have NATO. So technically, we speak English because they are like the highest military power, and then we use it as a lingua franca to communicate. In Europe, before English, Latin was the language that was used because the Romans were the ones ruling the world, you know? So depending on who rules the world, we use one of the languages. Right now, I'm in Latvia, for example, and here in Latvia, Russia was the guy who called the shots. So a lot of people speak Russian here, for example, and are just, since they joined the European Union, are starting to speak English also, right? But for example, maybe for us it will be like if you speak French to me and I speak Spanish to you, probably it will be easier for us to understand that if if none of us spoke English than having to learn English and then communicate English and then like translate it again. And it's just agreements, like a lot of the culture has been pushed into people through domination, through war, through you know um but then lots of other beautiful things have happened through agreement. So I think AI is gonna just replicate the agreements we have as humans. So if we agree that killing other people is bad and we don't do that, then AI won't do it either. But if we keep making wars and killing people, then AI is just gonna make it better and it's gonna kill better and it's gonna kill more, because I think AI is just a reflection of ourselves. So if I think the problem of ethics in AI is also a problem of ethics in humans, because we're only scared that AI is gonna do our sins worse, and faster and better than us. So
Mm,
then we need to agree more as humans, so as the AI doesn't optimize our disagreements.
mm, mm. Yeah, and that made me think of, for example, how is it different from building AI uh, in, uh, in 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 Qatar, for example, or in the US or in Europe? So how is it different from building AI in those different countries based on the legislations? And I think it's related to what you just say, because s- well, first of all, how would you describe how it's related?
First thing is availability of computing power. Like Amazon can't sell in Iran, for example, or in Russia or in China, you know? So, for example,
Mm,
these countries have to develop their own tools to do their AI, and availability of computing power in Europe is a lot different from Africa, just because
mm,
you have
mm,
access to so many cloud computing services. So that allows you, like, a person in Rwanda will not develop AI as fast as a person, even if they knew exactly the same as a French person, just because
mm,
of availability of GPUs. You know, so then like the first thing that is different is availability of GPUs. The second one is availability of money to buy those or rent those GPUs, right? Because
mm,
uh,
mm,
access to venture capital in the US is a lot better than access to capital in France, for example. You know, So or Spain or even Mexico, even when Mexico has been growing a lot. So then those are two key differences for startups. Then for corporates, of course, is regulation, because for example Mexico has lighter privacy regulation than Europe. Europe, you have the GDPR policy, so then
Mm,
it's easier to develop dangerous things in Mexico than in
mm,
Europe. You know,
mm, mm,
um, and for example, Qatar in the World Cup, they stopped selling alcohol because they wanted. So all the thing with Qatar is that they wanted to promote Islam, and like push Islam into the Western world through the World Cup. And of course they failed because we have a set of values completely different from them, so um, when there's also a lot of political agenda that gets pushed into AI in different countries. So because in the US it's all about freedom, no, it's like you have to be free to do whatever you want, and then in Europe it's like what is best for the community. So it's like, oh no, but you can't do it if you violate privacy. But then in Qatar it's like, no, but then it should be like something that promotes Islam culture in the world. And so everyone has
mm,
their agenda, and then we just enjoy being moved through the agendas of powerful people.
mm. Yes, it made me. Uh, well, I think this is something I will for sure look how AI evolves based on the countries, because you were mentioning that AI is a reflection of uh, what we as humans mm, like share and think, and the actions we take on little scale AI can represent that higher scale, and taking into account that some um, some yeah, like for example in Europe we have RGPD, and we try to legislate a lot of this, and when the legislation uh, is less, it can be scarier use of AI, and so
Self-driving
yeah, I
cars, no?
will
In California, autopilot from Tesla is legal. So like you can just put Tesla in autopilot in any California highway, which you can do in France. And
yeah,
we have more beautiful highways in Europe, but you can't use autopilot here because of regulation.
yeah, yeah, yeah. I will for sure look more into this. I was also wondering, in terms of contracts, like when you're a company and you want to implement AI, you were mentioning at the beginning, you're now starting with Erudit, trying to take into account into the models. I don't know if it's in production yet, but like some calls, some retranscription of audio, and put it as an input of the models you use to enhance the visibility of how the company is doing, if like people are burned out or mm, so in terms of these contracts, we think of the audio of Erudit, and at a larger scale, when we think of implementing AI in the direction and to humans in the company, how do we need to take that into account? Do we need to change the contracts? How does this work?
It's an excellent question. Yeah, it depends on the country. Again, like you, yeah, for example, most of the AI works better in English than in any other language. We have developed, because we're a US company but with origin in Spain. So then we have trained also in Spanish and then just moved to English everything, because everything works better in English in AI, just because most of the work in AI it's either in Chinese or in Russian or in English.
Mm, mm,
And then you as a French person and I as a Mexican Spanish person, I have developed a lot in Spanish, but then
mm,
I always have to do the English version to be able to deploy international.
mm, mm,
So like it depends on the country. Of course, our product is sold mainly in the US market because the US, not only legislation but culture, is more open to these kinds of tools, because For example, here, if you try to sell to the Germans, the unions will jump immediately to your throat, you know. And
mm,
in
mm,
Europe, unions are more important. Like in the US, there are few or no unions at all, you know.
mm,
And here in Europe, like you have to, like, especially in countries like Germany or France, you have to target the unions first instead of individual workers. In the US,
mm,
like any company is able to deploy whatever they want, and they are already using a lot of email analysis. And in the US, any manager can go and read any of their employees' messages, and that's
mm,
unthinkable in Germany, you know.
mm,
Then here in Europe, uh, there's a lot of compliance. You have to work with unions, talk directly to the employees. In the US, you can do pretty much whatever you want. So then, and in the US, like most of the contracts already have policies that pretty much whatever you do in company's property is from the company. So then, I think as a worker, you have to read more carefully your privacy policy, because we are so used to being shown privacy policies that we are numb to privacy. It's like, do you accept cookies? Yes, 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 yes. Like that. I think that's one of the biggest failures of GDPR, that people do not have the time or the patience or the knowledge to read privacy policies. So of course, do you accept the cookies? But those cookies could save all of your keystrokes, for example, and nobody reads, and then they give consent to getting all their keystrokes saved, for example, you know? And then what's the use
mm,
of GDPR? So I think
mm,
one of the main problems is that the legislators are not technical people. Like, not in the case of Europe. Europe gets a lot of advice from technical people, but there are a lot of countries where, like, the people who write the laws and the people who know about these things don't communicate at all. And then you have a bureaucrat writing whatever he thinks is gonna be important and knowing zero about coding. You know?
mm. Okay. Okay. So yeah, very interesting. And again, this is 360 vision where like something in Europe is different from something in the US, is different from something in Mexico. And that's I think yeah, that's the main also one of the main things that I will note to myself is like the region where you are
Yeah.
really change everything. And also to everyone who listens to us, read your policy, read your contracts.
Send it
So
to a
you were
lawyer.
talking.
Any friend,
What did you say? Sorry.
any friend that is a lawyer, just send it to any friend that is a lawyer.
Exactly. Yeah, so yeah, to do list. Have a friend that is a lawyer. I was wondering. We were talking about governments and AI at a big scale. How do you develop and put in production a model for a government? How does that work? Could you give us visibility on this, or is it?
Also depends on the government, because, for example, China has complete control over their citizens. So people think, like, why does China develop so fast? Like, what's the main difference between China and the rest of the countries in terms of technology and science? And is that in China, everything that the government approves is legal. So then, if they want to clone people, or like extract organs from people, or like do whatever in Europe would be horrible, they can, and they don't care. So then there have been lots of experiments in humans, and lots of, like, uh, any kind of cell lines, and like there's no regulation whatsoever. Only the Chinese Communist Party has to approve it or not. And if you are high ranked in the Chinese Communist Party, you can do whatever you want with any Chinese person. So, and then there's the concept of privacy doesn't exist in China. So then the government can read all of your emails and can know everything that is happening in your computer, can control which websites can you watch. So of course, if you have no ethical compass, and just care about, like, developing technology, sell to China. That's the best thing you can do, because there's no regulation in China. uh, if you want to develop in Europe for a European government, like, it's awesome all the amount of data you have available. So I think one of the best things of Europe is that you have a lot of very nicely cleaned, organized data sets to train. So you can do anything inside of the European Union from data.europa.eu, or I don't remember. But if you look like European data portal, uh, you can get data sets for free, crazy, beautiful data sets, but it's only for the European market, you know? And
Mm,
if
mm,
then if you want to work in the US, everything is private in the US. So then there's no real government, so bureaucrats and contractors, you know. So then
mm,
you have to
mm,
work with other 30 different companies to do anything in the US. Of course, in
mm,
Europe you have a crazy amount of money, and like they don't even ask they only ask what are you going to use it for, but they don't ask for you back. So you can create an amazing 2 million euro project with public data sets in Europe funded by the European government, which you cannot do in the US. You know,
mm,
in the US
mm,
you have to raise private capital and you have to work with private contractors. So it's super different. Like if you work in any British country, UK, US, Canada, like it's mostly gonna be private. It's mostly gonna be paid by privates, and it's mostly gonna be a lot of private companies doing services. And if you work
mm,
in Europe, it's mostly gonna be the government paying for you. It's mostly gonna be with open things. If you work in Arab countries have a crazy amount of money. It's like insane the amount of money they have. But then a lot of things are about controlling people. It's like, how do I control my borders? How do I do facial recognition? How do so then your moral compass, it depends on your moral compass. Like you can do amazing projects in the Arab countries, but then you have to think your values first before you work there. Because think how many people died in Qatar in the World Cup, you know, building the stadiums. So
mm,
it depends on the person. Like if you're a money driven person that just want to get rich as fast as possible, go to the US. If you are a person who wants to build something sustainable and like good for humanity, and that is like the next step, work in Europe. If you want to build something super powerful with almost no regulation limits, go to with a lot of money, go to Arab countries. If you know, Africa is also very interesting, and people don't look at Africa much, but Africa has a huge population. It's 3.5 times the population of Europe. uh, it's starting to have money because of Chinese people. Chinese people are going into Africa, building factories. So because Chinese lower class is becoming the middle class now. So in Europe, it was like, oh, I don't want to do this. I send it to the Chinese, you know. And now the Chinese are rich. So now the Chinese don't want to do things Chinese people do. So now it's like, oh, Europe sends it to China, China sends it to Africa, and then like it would be a lot smarter if Europe just started sending things to Africa instead of passing through China, right? But we don't.
mm,
So then like I think Europe needs to start investing in Africa, because if not, Chinese people are gonna take over really really fast. And Chinese like African people now have more money than we think normally. Their
mm,
cities are starting to be more developed, they are getting more bankerized. So Africa is growing, and then it's a nice market to look at to sell to governments, because they don't have all the things we take for granted.
mm. Yeah, it remembers me of the Jumia story, uh, like how Jumia came into Jumia, which is kind of like the Amazon of Africa, and
Okay.
I think it was an ex McKinsey that decided to. He was working between Paris and the US, and he decided to launch this. And they've built, and so the fun thing about it is they built a lot of the projects like to replicate the models, but a lot of them they had to close it afterwards because it wasn't working. The market wasn't mature enough, and
Yeah.
so that like so they built a lot of a lot of jobs for people, but when you need to close a branch, you also make a lot of people lose their jobs. And what you were saying made me think of what we were saying before, which is like how tools and how the world is going today, is it enhancing those inequalities, and how what are the possibilities for, like, for example, Africa in terms of technology or general terms, but also South of America. Uh, how do you manage, because Europe and the US and the East have a lot of money and are able to build a lot of things, but how do we manage this inequality? This is one thing that I really look. Maybe if you have an opinion on this, but this is a
AI,
very wide question.
because like think about it, like if US is rich, Europe is rich, then they used to send everything to the Chinese. Then now the Chinese send it to Latin America or Africa. When the Africans and the Latin Americans get rich, who is gonna do the things nobody wants to do? You know.
Right.
So then,
Yeah.
because you cannot put monkeys to do it, or maybe we invent a way to put monkeys to build things, but like at some point, like all low wage jobs have to go somewhere. So I think the first thing we are going to automate, or that it makes sense to automate, is all the low wage repetitive jobs,
Mm,
you know?
mm,
And the problem is like, at what pace do we do it? Because if we automate what African people is doing now for the Chinese faster than we can make Africans rich, then that creates inequality, because then you
mm,
automate Africans without Africans being rich. So you
mm,
just need to first make Africans rich, and then maybe hold the technology for a bit, and then when African people are already middle class and don't want to do those jobs, then you automate those jobs, you know.
mm,
Because if you, because the technology is growing faster than we're making humans richer, so we need
mm.
to balance creation of abundance for humans before
Yes.
we put robots. And like that's a problem, that if rich people want to get rich by displacing poor people, we're going to have a population crisis, we're going to have a food crisis, or then we need to start thinking about welfare states, like Spain did. For example, Spain has universal basic income approved, so you can't,
Mm,
if you're a Spanish person, you can die, like because the state will give you 700 euros, you know,
mm,
just because you're Spanish. So maybe we need to start thinking about that. Maybe like, okay, if we can find a job for this person, and there's a robot uh, making the job of this person, then maybe I
mm,
charge some tax to the robot, or the robot owner, so that I can take from that and maybe re-skill this person. I think
mm,
most of the money that AI makes other people lose should go into reskilling people, so that they go higher in the socioeconomic
mm,
class, you know. Like if you're gonna put a robot to do manufacturing, then that robot should pay taxes, so that you can reskill manufacturers and maybe make them lawyers or doctors or whatever, you know.
mm, mm,
And so on and so on, because we just don't need to forget that if it's a war, AI versus humans, we're always gonna side with the humans. You know? So we need to remember that, like that when we have imagine the Martians come, like we're that will happen before in with wars, right? Like people who hated each other, when they had a common enemy, they would join and become allies
mm,
and forget all about their differences, you know. It's the same
mm,
thing, like we don't have Martian wars, and but I think in the end we have to remember that if there's a Earth versus Martians, or a humans versus AI, in the end we're gonna
mm,
side with humans. So then
mm,
we need not to forget that in that progress we're making, in the end we're
mm,
all the humankind. You know?
mm. Yes, yes, it's very inspiring. I think, yeah. I really look forward to learn more about different economic models, like how to manage taxes for, like, based on what AI is doing. But I feel like what you shared just give an insight of realities
I'm not
that
worried
would
about
be.
Europeans. Like Europeans is the less worried I'm about, because probably this is gonna happen. Like they're gonna tax somehow. because even to people, if I pay for a 3% tax, like even to
Mm.
people, if you start getting richer, they
Mm.
tax you more, and then it goes back to make other people richer.
Yes.
I am not worried about Europe. I'm mostly worried about abusive states where you have like a 1% uh, class and then 99% people dying of hunger.
Mm. Okay, awesome. Thanks a lot for sharing all these thoughts. I think we've come to an end for this episode. I have maybe three little questions just to finish this episode. The first one is for the people who are listening. How do you, on a daily basis, improve yourself, and how do you get better, and how do you keep learning?
I'm fat, man. Like one one of the first things I would advise is don't forget things that are not your brain. Because
Mm.
that happens a lot when we're in a intellectual world. Like you always feed the brain and worry about the brain and do everything about the brain, and then you get fat and your knee hurts. And so I think if I were my 21-year-old self, the first thing I would advise is also eat well, sleep well, don't drink too much alcohol, and go to a gym. Because if not, when you're
Mm.
30, your knee hurts, your back hurts, and you're fat. So then
Mm.
it's not all about brain. And also having friends and going partying, and like there are so many things that are not just the brain that you should also take care of to
Mm.
to still keep a good brain. Because normally on a Monday or in the weekend I went partying and I saw friends and I saw family, and I slept and maybe had some physical activity whatsoever. I'm more motivated to work on a Monday than if I read something super interesting.
Mm. Okay, so no, so just get out there,
Get
do
out
some
of your
sport,
brain, get out of your
drink water.
chest.
Okay, awesome. If people want to learn more about you and your work at Erudit, or everything you're doing, how can they connect or see your work, or read your posts? How should they? How could they see more of what you do?
Yeah, I have a website, ricardomichel.com, where
Okay, I will put it in the description.
some like every once in a year or something, I just copy paste all the things that other people have said about me there. So it's a collection of like articles and podcasts and conferences and interviews. And so then, because for example here, right, like there are lots of things that we have discussed that are information that I would not normally say, you know
Mm.
unless asked. you know
Mm-hmm.
so then I think to just learn about what I have lived with so many things, governments, companies, whatever, there,
Mm.
and then reaching me personally, normally through LinkedIn, or just my email. I don't know. Everything is there in LinkedIn, like my email, my phone, everything is there.
Okay, I'll make sure to post the links. And last question of the podcast. And before asking this question, I want to thank you again for coming and sharing your time. I really appreciate it, and I hope the people listening too. I've learned a lot in this 1 hour episode, a little bit longer than usual. Last question. Do you have a message? I mean, I think you shared a message regarding like get out there, get out of your way, and like exercise, drink, have friends, have fun. But do you have a message that is maybe mm, a point of view about AI, about Erudit, about psychology, language? What's your message? The message that you want to share for closing this episode?
Sure. I think from all the things I've lived so far, I'm gonna be 30 next year. And I started coding when I was 8, so I've been coding for 22 years. And from all those years, I think first thing is I would have done AI faster if I knew more math, uh, and I would have known more math if I trusted myself more. and if I were more patient. So I think try things even when you know you can fail until you fail. Like let the world prove you wrong. It's like if you said I can't, better say I can, and I'm just gonna think and have faith I can until the world proves me wrong. You know
Mm.
and then
Mm.
and if I'm gonna try and make my company unless until everything proves me that I'm unable to do a company. But just gonna have
Mm.
faith I can until everything shows me that I'm a complete failure, because most of the times you don't fail. Like I have built so many things that everybody told me it was crazy or stupid and undoable, uh,
Mm.
and I just kept trying until it worked. And I failed a lot of times also. Like before Erudit, I failed 8 or 9 times. And but I had other successful companies too. Um, and it's just that, like, just let life prove you wrong. And then, like, friends are the most important thing. Like, I couldn't do anything of the things I do without good friends. Like most of the things I've done, it's because a friend introduced me to a VC, because a friend gave me feedback on some idea, because a friend introduced me to some supplier, because a friend introduced me to some customer. Like
Mm.
I think my friends are responsible for a lot of my success. And
Mm.
it's important to take care of people. No matter if you're super busy and you have 1,000 things to do, always have time for friends, I think.
Mm. Okay. Thanks a lot for this message.
Okay.
And thanks a lot for the episode. I wish you to have a wonderful day,
Okay.
and see you soon.
Awesome. Thank you so much.